In this video, we'll be going over the bottom-up approach of palindrome partitioning. Let's go over the thought process. So let's convert the top-down memorization approach to a bottom-up approach. Now, where do we start? In the memorization approach, we have cached the starting index I with the palindrome partitionings, or palindrome partitions, with all starting index I, or palindrome partitions results with all starting index I. This means we can create an array results to keep track of the palindrome partitions for all possible values of I. Now let's go over the pseudocode. So we're going to create an array results to keep track of the palindrome partitions for all possible values of I. Now the indices represent palindrome partitions. The indices represent I, and then the values represents palindrome partitions. Now we're going to iterate through from s.length to 0, which is denoted as I. Then if I is out of bound, or if I is equal to s.length, this means we cannot form a palindrome partition here, so we can just add an empty list to our current index. So we're going to add an empty list to result I. Then we're going to continue to the next iteration. We're going to create a string builder to keep track of our current string. Then we're going to iterate through the indices from I to s.length minus 1, which we're going to denote as j. We're going to append the current character at j into our string builder. To string builder, and then we're going to check if our current string is a palindrome or not. If the current substring from I to j is a palindrome, we want to iterate through the palindrome partitions starting from j plus 1. Starting at j plus 1. We want to prepend the current substring into all of the palindrome partitions we found at starting from j plus 1. So we're going to create a list partitions. Then we're going to add the current string. So the current substring to partitions. Let's denote this as so the palindrome partition starting at j plus 1, we can denote it as PAR. Then we can add all of PAR to partitions. Then we're going to add partition to results I. Then we can return the results starting from index 0, which means the palindrome partitions if our starting index is equal to 0. Now let's go over the code. So we're going to create a list results, an array results, to keep track of our palindrome partitions for all starting index I. Then we iterate through the indices from s.length to 0, denoted as I. If I is out of bound, this means we cannot form a palindrome partition, so we're going to add an empty list to our current index. then we can just continue to the next index. We're going to create a string builder to keep track of our current string. Then we're going to iterate, do the indices from I to the end of the string, denoted as j. We're going to append the current character to the string builder. Then we're going to check if the current substring is a palindrome or not. If the current string is a palindrome from I to j, we want to iterate through the partitions starting from j plus 1. Partitions starting from j plus 1. Now we want to prepend the current string into each of the partitions to create a new partition starting at index I. We're going to add our current string first. Then we're going to add all of the partitions from PAR. Then we're going to add our current partition to our results. Then we can return our palindrome partitions starting from index 0. Now let's create the helper method, which will help us check if our current substring is a palindrome or not. So while I is less than j, we want to check if our current characters are the same or not. If the current characters are not the same, then it's not a palindrome, not a valid palindrome. We can just return false. If they are the same, we want to move our pointers closer together. So we increment our I and then decrement our j, post decrement and post increment. Then we can return true after we have checked through all of the characters. Let me know if you have any questions in the comment section below.